So the idea of rest energy is an interesting one. It says that just by existing, a mass has energy associated with it. So we've seen that what we call rest energy is the famous E equals mc squared. And so what I like to do is just compare that to some other kinds of energies, such as kinetic energy and chemical energy. So to begin with, let's just look at how much rest energy there is in 1 kilogram of any substance. So if I just put in 1 kilogram and multiply by the speed of light squared, I'll get 9 times 10 to the 16 joules. If I think about something like gasoline, gasoline has an energy that if we were to combust the gasoline, just burn it by oxidizing it, the energy that we would get from that is what we would call chemical energy. And for gasoline, that's 46 megajoules per kilogram. Or I could rewrite that as 4.6 times 10 to the 7 joules per kilogram. So if I compare the rest energy of 1 kilogram to the chemical energy of 1 kilogram of gasoline, what we see is that there's approximately 10 to the 9 or 9 orders of magnitude difference between the two. So the amount of chemical energy that we get from burning gasoline is much, much smaller than the amount of energy that we see in the rest energy. And just for further comparison, let's consider a car. And a car might have a mass of approximately 1,500 kilograms. Highway speeds are somewhere on the order of 30 meters per second. And so if I were to calculate the kinetic energy, remember that's gamma minus 1 mc squared. First, let's calculate gamma. And when we do that, we will get these 3's will cancel with one another to give us a 1. And then so we essentially have 10 divided by 10 to the 8, which would be 10 to the minus 7. So 1 over 1 minus 7 squared. That's the same as 1 over 1 minus 10 to the minus 14 square rooted. That's essentially 1. So we would have 1 minus 1 mc squared, which is 0. You can see that the kinetic energy is very small. And so to get an accurate calculation of what the kinetic energy actually is, we need to go into our classical formulation of kinetic energy. So when gamma is small, we've seen that we can rewrite this as 1/2 mv squared when the speed is much smaller than the speed of light. And so then the kinetic energy will look like 1/2 times 1500 times 30 squared. That's 750 times 900. And if I multiply those together, I'll get approximately 6 times 10 to the 5th joules. So that's 2 orders of magnitude smaller than the amount of chemical energy that's in 1 kilogram worth of gasoline, and it's 11 orders of magnitude smaller than the amount of rest energy that's available in 1 kilogram.